How do you want to do I start or do you start? How do you want to do it?
I've forgotten what the start is, but let me introduce it. So we do system administration training as well. We like to do that first at a site and for our system administrators, but also for users, because you may be installing some of these packages on a workstation or in your home directory. So understanding how to install the software is really important. And we find that most sites we go to, the software is not set up well. That's not the fault of the sites, it's the fault that we don't have a lot of instructions. And our system administrators are generally very pressed for time. So I always imagine that you got a university, they get this new hardware, the system administrator has 1 day to set it up. That's it. So we're trying to make it as smooth as possible to set up the system. We're looking at more advanced techniques like binary distributions to help get things set up. There's just so many variations of software and things like MPI that it becomes hard. So let's go ahead to the next slide. Why don't you go ahead and start off?
Okay. Thank you, Bob. So yeah, so as Bob already said, this is intended to be both for sysadmins and for users, because even us, oftentimes we are on a system that we don't have sudo privileges for, and so we have to install software in our home directory. So the scripts that we'll mention here, they have sudo in them because we use them on Docker files as well. So we use them to build Docker images, but there's a test that's done on the script on the install path. And if the install path exists and the user has write access to it, then sudo is basically removed. So you can use the scripts as they are if you provide a path that's in your home directory and you have, or anywhere you have write access to, and they'll work as well for you. Yeah, so we are doing our best to provide a comprehensive set of scripts, and we're always adding something. Lately, we've been adding quite a lot of stuff, but as I said before, if you have a tool or a specific package that you think it's relevant for you or for the community there that you think we should add, just let us know and we'll add it, or you can even add it and then just make a PR and we'll include it. So this is public, it's open source, and we're trying to get the help of the community in building this for everyone that wants to use it. So this presentation has several bullets. We're not gonna be touching them all today, but this is just to show you, what are the things that we cover normally during this presentation. And I'm pretty sure there's a couple more that we actually didn't include in this list. So we try to make this very comprehensive, start from the beginning and then add on to the detailed analysis of what you can do to set up your cluster. So yeah, so in terms of the overview, well, there's always the question about who's gonna be using the system, what usage is gonna be the one that's on the system. So is this just gonna be single node or multi-node? Do we want to always have the latest versions, or do we prefer a stability? Is this going to be mostly HPC, or will there be any AI as well? So all these questions kind of contribute to shaping the software stack and the approach that you might want to have in your software on the cluster, basically. And I should say, Bob and I think it's fair to say that we are mostly from the HPC world, so we like modules. And when we talk about modules with the AI folks, they're always like, "You mean Python modules?" And we're like, "Well, not exactly." So, if it's mostly AI, maybe it makes sense to wonder if there should be more conda than modules. But we like the modules. So all of these scripts that we'll show you will set up a Lua module, even for the Python packages such as PyTorch, TensorFlow, and so on. So we're gonna handle the Python tab for you with the modules. In terms of supported hardware for these scripts, we have pretty much all the AMD Instinct GPUs as supported. We've got some workstations, and there's actually a list of the hardware that's supported for ROCm, but that list is the list of that hardware where testing has been done. So it's possible that others that are not in the list may also work, and we've actually seen that. I think Bob has seen that firsthand. Um, yeah, and in terms of supported OS, so we are mostly focusing on Ubuntu. Before we were focusing on 2204, now we've switched to 2404. And we are working harder and harder to also include Red Hat, Rocky Linux, mostly, and SUSE. So all of what we're talking about is in this HPC training doc repo that you have heard of so many times already. And we have two different flavors that you can select to leverage the scripts that are available for you. The first one is the one that kind of originated the whole thing, which is building an image for a container to run. So that's basically why initially the scripts would have sudo in them, because they were run by Docker. And that's how also the training that we would do was initially set up. So Bob created this workflow where we would build an image separately, and then we would push that to the cloud. And that workflow is available for you as well if you want to do it. You can basically just do the same thing that we're doing for our trainings. But we have kind of expanded that scope to adjust the scripts, as I said, so that they can also be used not just as bare metal installation for sudo users, but also for regular users that don't have sudo privileges. So with the container, it's mostly based on Docker, even though Podman works as well if you have that in your system. And we also have a couple of recipes on how to build a Singularity image using our scripts. It's not the same as Podman or Docker. Podman is intended to be a drop-in replacement for Docker, so the two are very similar. But we have worked on a recipe that will allow you to create an image for Singularity using our scripts. Yeah, so we have added a couple of detections in the script to use Podman instead of Docker if Podman is installed instead of Docker. And you can find the Singularity instructions in the README. So for what concerns the container approach to build the image, so actually the container is set up to use Ubuntu 2404 now. That's the default. And it's created in a way that it initially pulls a bare image according to the distro that you have supplied when you run the script. So if you don't supply anything now, it'll pick Ubuntu 2404. It gets a bare image with this OS. And then on top of that, it builds a new image that we call ROCm that has all the ROCm and ROCm related software. Then from that, a new image is built with the communication libraries. from that the tools, and from that the extras, which is basically anything that doesn't fall in either raw comms or tools. So there's obviously a ton of different flags that you can supply to that build Docker script. These are just here to give you an idea. So we always suggest that you first run it with the -- help so that you can select from the menu the ones that are relevant to you. And these here are off by default. So basically, you can pick with which packages to build. MPI will be built by default, but these you can pick. This is just a visual image of what the process that I just described entails. You see the script builds an image from the distro. Then for the ROCm image, it calls all the scripts that sit in the ROCm directory. For the com image, it uses all the scripts that sit in the com directory, and so on, moving like that. This is just how the image can be run with Docker. So notice that we are using the -- device to make sure that the drivers for the GPU are going to be visible from the image. We're adding the user to video render and audio. We're going to run the container in the background. We're removing the container once we log out, basically. And then we are mapping the host directory to the container. And that one last rectangle is the image that we're running. The other approach that we have is the one with the bare installation. So we have two scripts that are relevant for this. One is called test install and one is called main setup. So test install is the script that tests main setup. Main setup is like the red button that you push when you want to deploy all the installation, and main setup basically just calls each script one at a time and installs in the bare metal. Test install gets you on a container first, on which, if you want, you can call main setup. There's obviously many options for those as well. But this is the flow chart for this approach. So if you run test install, then you'll be put in a container where you can test main setup before you actually deploy it in the wild and install software in your system. There's a quite useful flag that we introduced that's called --use-makefile. So if you set that one to 1, then basically main setup is not gonna run any script. You'll just be inside the image, and then you can install each script. You can run each script separately just by doing make and then the name of the package you want to install. If you don't set use makefile, then main setup will install all the scripts, or install all the software running the scripts, and then you'll be on the image where the software is already installed. Oh, sorry. Yeah, so these are the flags that you have. Let me just point you to the Python version, which is the minor version for Python 3. So, well, default was 10 when we were doing 2204. Now it's 12 because we're doing 2404 for Ubuntu. And this is the target architecture that you want. So this is particularly important because we often cross build. So we build on a system that doesn't have, for instance, 300As. We build on a 200, but we specify the GFX model to be GFX 94.2 for the 300 series. So once the software is built, you're not going to be able to run it, but you can still move that image to a 300A, for instance, and there it will work. So yeah, so these are the scripts that are called by the main setup. I divided them up so that the first batch you see is for ROCm, second batch for COM, then you've got tools, and then there's the extras. Notice that among the extras, there's a few of the most wanted here, particular JAX and PyTorch, and we've got TensorFlow as well. Yeah. So I'm gonna hand it to Bob for the ROCm installation, I think. If you're ready, Bob.
I'm ready.
Okay. Do I keep sharing or do you want to share?
You go ahead and share. Let's go next
Okay.
slide.
Okay.
ROCm installation is the starting point. There's quite a bit of documentation on ROCm installation, but it seems to change quite frequently, the details of what you have to do to install different packages. And ROCm is a very large software stack today. Here's just a small list of the packages that are in the system. Let's go on to the next one. So this is showing a bird's eye view of all the software, and it's growing quite fast, especially with AI coming on the scene. Just yesterday, they announced a new build system called the ROC, or ROC-K, I think is what they're calling it. And they issued a release called 7.9. So they jumped from 7.1 to 7.9. I'm going to warn you right now, don't install it. It's a test version that they hope to find all the bugs in this new build system so they can release ROCm 8.0 in about 6 months. So it's not something you should be installing unless you're experimenting, okay? It is not the next release in the 7.1 series. But because of the complexity, how much you got to build, and that a lot of sites don't want all the software, they have a particular niche they want to have. So there's going to be a special set of packages for HPC sites. And then they have one for bio, and I've forgotten, there's a couple other they're planning on having. So you see all this software, there's millions of lines of code in there. Almost all of it is open source, and you can install any part of it. For example, in the libraries, I can do a SPAC install ROClaws and use SPAC to install just that package. And maybe I just want the latest release of that. So unlike NVIDIA, which has a single binary you install, these are separate packages, open source, that you can mix and match and install different versions. It is very important to keep your paths clean. And we spend a lot of time on that with Python in particular, but even with ROCm, you don't want to mix ROCm versions because it's unknown, especially with tools, because it's unknown what will happen if you mix tool chains and ROCm versions. Okay, so we see all this software. Let's see how we're going to install it. So in this screenshot, we see the GFX codes. If you install the generic package, you're going to get all of them. When we do the ROCm install, we specify which GFX model we want for all the software. Some of them it doesn't matter, and some of them it can make a huge difference. PyTorch, it compiles all these modules for each GFX model, so it can make it much, much longer to build and much larger in size. Right now, we're supporting 2 versions of Ubuntu, Red Hat, SLES, Debian, the Red Hat clones. This tends to rotate every release. They will add a new version of each of these and drop an old version. So that means that they're tested. It's best to stay on these versions, but for example, some of the older versions of Red Hat are also work fine. They're just not supported as and tested as well. Next slide.
Sorry, I think some of these slides have a timer, so if you see them change all of the sudden, that's for the timer. I apologize.
I hate that. They turn that on by default. Let's go next slide. We talked a little bit about OSs. So in the ROCm installation, there are multiple ways you can install. In this presentation, we mostly talk about a single ROCm release because in a Docker image, we're trying to keep the size smaller. If you notice on AAC6, we have multiple ROCm packages installed. If you do have multiple packages, you have to be careful about mixing things. We don't want to use a tool built with 6.4 if we've got ROCm 6.3 loaded. You can use the lower level package manager to install, and we'll show a little bit of that here, but generally we do use cases. So we have a script on top that grabs a whole bunch of the packages and installs them as a set. There are numerous articles on this ROCm installation process, and the ROCm docs is here is probably the thing to look at for the most current information on installation. In our installation, we're going to install all these packages. Older version of ROCm, there were only 2 packages, so it keeps changing. And so you may want to do this list use case to see what list is currently there. Go ahead. Okay, so we have to get a key for the ROCm software. We're going to go ahead and get the install script, and we're going to run that install script. And that is that's just going to install the packages into our list of packages. So then we have to go ahead and do the installation on the next slide. So here is where we do the list of packages we have to install. Older versions, less than 6.2, we had a different list that we installed. We had a question here earlier about the address sanitizer. We do not install that by default because it doubles the size of the image, but you can install that. I would be selective with that unless you have a lot of disk space. It made our Docker image too big to work with. And ROCm ASAN, the address sanitizer, is only available in certain versions. So here we're not installing it with 2404. We had to do that with 2204. Next slide. I think it kicked me out, so I got to look at the screen.
No.
I think the network kind of flaked on me. Okay, so we can run ROCm SMI to find out what GPUs. So this is showing that we have 8 MI250 GPUs on the system. And that's always good to run, make sure we can access that. Next one. So this is verification that the GPUs are available. We can also use AMD SMI. It'll give us more information. We can also use ROCm info. Next slide. So at this point, we know that the GPU is working. We've got a pretty good indication that ROCm is installed. We have gone to some sites and we have found that they had no working system at all. So it's really important to do that. And even if you log in to do some exercises, you'll find out, well, I didn't use -- GPUs, so I don't have GPUs available. So those are good checks to see that they're available. Now we're going to talk about modules, and the installation directions in the ROCm doc site does not really talk about modules. Why do we want to use modules? Well, I installed Conda on the system one time to help the AI guys out, and it broke all our profilers because we got conflicts on the Python. So we're trying to isolate everything. When you load a package, you are getting the paths to that one, and when you unload it, it's not going to conflict with anything else. So we don't want everything in the path. We don't want every Python in the path. If we had every Python in the path, we would have half the files on the system there. So let's look at modules. We use Lua modules. TCL modules are similar. And so we do that module installation. We have to do that early in the script. So at the end of every installation, we install a module. And you can use that as a template, what you might want to do on your system. What you might want to put in your modules, what paths, what load library setting you may want. Next slide. So this is, these are always out of date because it changes so fast. But in this list, we have, even on the ROCm install, we have about 6 modules just for ROCm. So we don't load the AMD Clang compiler if we just want access to the ROCm libraries. So you'll see a ROCm module. To get the compiler setting, we load AMD Clang. To get the AFAR, we load AMD Flang New. So we're segmenting what you are getting into the path. I want to make well, I think we talk about ROC profiler compute later, but I want to give you some cautions about that one. And then we have all this software that we add on top of the ROCm install. In AAC 6, since we're going to have multiple ROCms, we have a hierarchical system where when you load ROCm, you see all the software that was built using that ROCm version. That's to try to avoid conflicts. We had a lot of cases where people on some of the bigger sites, they would install a new profiler and it would crash, and we don't know why, but they have a mixture of ROCm versions, drivers, all sorts of issues, and it makes it very difficult to chase those issues down. That's why we're really excited to see the tools being integrated into the ROCm release. Let's go next slide. Okay, so for ROCm, we have 1, 2, 3, 4, 5 show Omnitrace, which is now ROCprof Sys and ROCprof Compute. But we show 6 modules we load with just ROCm, so that we're not getting everything when we load the module. We try not to pollute the path. And then we've broken up what we call ROCm Plus as anything built with that ROCm. And here we had broken them up into several categories. We're not doing as many categories right now, but you might still think of them as different groups of software, like the communication, all the MPI tools. Next slide. So here are some module commands. Module show is really valuable because you can see what settings we're doing for each of the modules. If you're setting up your system and you still have access to AAC6, you might look on AAC6 to see what we set. These are continually changing as we learn, you know, about problems or things we should set or shouldn't set. So we're trying to get the minimum list of things that we need to set for each package. Next slide. Okay, job schedulers. Let's jump into that one. So we basically support Slurm. And what we didn't really mention, when we build a Docker container, it's like a mini HPC system. And it really confused people when we said, in the Docker container is Slurm. It's also SSH, so we can have all the users SSH into the container. So it's like a mini HPC system, but one node. And so we install Slurm. We're going to look at adding PBS because we have some sites using that, and we want this to be something that we get a bug report, we can test it and see if we get it on our system too. And the nice thing about the Docker container is if we get a report that we got a problem with Red Hat, we can, or let's say the next ROCm release, we can build that particular release and test it. So we don't have to have 20 systems out there. We just build the system that is similar to the one where we've gotten the report, the problem report. So this is building Slurm and setting it up. We currently on the AAC6 system, we have a basic Slurm setup, but we're going to be adding a lot more capability on there so that we can keep users on it longer and just restrict how long they could run a job for, so that we can share those nodes. So these are the steps you would have to do on your system if you wanted to start Slurm up. Next slide. Okay, testing the success of the installation. This is one of the parts that a lot of people are missing. So we've been talking about these training examples here that you're doing exercises with, but we also check that out and then we run the test suite. We have 330 tests in that test suite. Now, if you don't install all the software, some may fail. But it tells you, is OpenMP working correctly? Is HIP working correctly? Are the tools working correctly? And so it's a functionality test after we do the installation. If we're doing this separate makefile build where we're testing the installation scripts, we'll do something like make kupi, and then we'll do make kupi tests. And that will tell us if our installation script works. So we test things. Let's say we get like the ROCm 7.0 release. We'll get that out, install the ROCm 7.0, and then we'll test each of the software packages and see what is working. So this is how we test. We'd rather test in a Docker container than on a real system. This makes a mess if you test on a real system and it starts failing. Okay, so let's see what the next slide is. So here is showing how to run the tests. We're going to go ahead and we can build this Docker container, or on the AAC 6 nodes, we can check this out and we just run this script, run tests. And it will go through 300 tests. It takes about 2 hours. So we can test whether OpenMPI is working. We can test almost all the exercises you've done the last 3 days. Next slide. And this is showing if you do the bare system install where we test individual packages, you can do make package tests, and then you can actually tar up the package and move it to another system. So you can build the packages that you install on a workstation, supplying the right GFX model, and then install it on your real system. And we do that for ROCm. That we've had some sites, they don't want it in /OPT, and they don't want to have everybody with super user privileges. Next slide. So this is the pre-built binary distribution of ROCm. So we can do make ROCm package, and it will tar up that whole directory, and then we can move it to wherever we want. There's also some utilities that they've added to build custom ROCm versions if you look at the ROCm docs site. Next slide. Is that it? We're skipping?
I think, yeah, this is all we have.
Okay.
Were you looking for MPI or the AI package?
I was looking for the MPI installation and maybe the tools, RockProf Compute.
Let me get there, yeah.
We have like 100 slides here, and we're not showing them all. For obvious reasons. You can read, but I want to bring out some points that you will encounter. We talk about creating GUI interfaces to an HPC system. We won't talk about that here.
There's yeah, this one here has those remarks. Is this what you were looking for?
Certain versions of ROCm, they didn't have the tools fully integrated. So you actually had to go in there and do a apt-get install of Rock Profiler systems and Rock Profiler Compute with ROCm 6.3.0. And a lot of sites didn't do that because it wasn't included in the use cases. The other thing I wanted to note is that Rock Profiler Compute requires some Python packages. So if you try to run that on a lot of systems, it will complain that it's missing files. So we actually install those Python requirements in the ROCm distribution and set a Python path to them. But that isn't done on every site. So you may find you get some warnings and errors with RockProf Compute on many systems. So I wanted to warn you about that. It's not that they're broken. It's just that they have to have these Python packages installed. And then can we jump to the MPI?
Yeah.
So later versions of ROCm will install the tools without any special, without having to do anything special, but they still are missing the Python packages. So let's go into OpenMPI. We had some questions on that. OpenMPI is actually kind of hard to install. And we've got MVOPITch and OpenMPI. We only install OpenMPI on Ubuntu. So let's go into the. So the sequence you got to do with OpenMPI is you first need to install xpmem, which is a kernel mod that requires sudo, and it helps with scalability. If you don't install it, you can still get it to work, but you may not get as good as scaling. We don't install it in the container because we cannot do a kernel mod in the container. UCX, now we install UCX first, and then we install the Unified Collective Communication Library. A lot of people skip the collectives. They don't know that you have to install that. That will again give you better collective performance. It's a fairly new package. And then we're going to install OpenMPI. Finally, get to actually installing that package. So there's 4 steps in here. And the script will show you what flags to set for each of the packages. So you may want to refer to the installation script for that. That's what's really important is even if you don't use the script itself, it records and documents what works because it's tested all the time. And we find sites all the time where they haven't installed all of those packages and they may not get the full performance. And then at the end, we create the module file. And we have generally built all of these with GCC. And then we set the OMPI variable to switch the compiler to whatever you're using for your application. So if I load up AMD Clang, it will set that for the MPI wrapper script. So that's often very confusing to people because you've got 2 different compilers you're using, one for your application, one for the system installation. Next slide. I think we may have a lot of detail, so we're going to just skim these here. So we do xpmem. These are it's not that horrible to do the installation of each of these, but you may not know all the flags to set. This is what will get you into trouble if you try to install it in your home directory, is you have to have these packages on the system. And you're going to need somebody to install this with that has a sudo access. And this is what we're having trouble with on our AAC6 is they got multiple PMix libraries on the system. So you get this error that PMix incompatibilities. And what's even worse is each node has a different PMix on it. So, and libevent is another one. You don't want multiple copies on the system. Okay, next slide. So now we're going to do UCX, and we're going to give it the flag to tell it where that xpmem is. Okay, next slide. And we actually, because we had a lot of trouble with network dropouts, we actually retest and reload the, restart the download if it fails. And we also check the MD5 sum for the packages. We don't do that for every package, but we do it for the MPI package. Next slide. Okay, and then and then we do UCC. So again, you need to pass where UCX is. We had to, let's drop back on that one. So we had an issue that it was failing for us, and Giacomo found a workaround on it, modify this CUDA LT file to get the right GFX model. And we worked with the UCC team, and they were detecting what GPU we were on. And in a Docker container, you can't access the GPU. So that was a mistake that they were doing, and they should have corrected it, but we actually have another workaround for that now. So that's why it's useful to see the scripts and how we have worked around issues. And Giacomo is really good at checking with finding somebody in AMD who knows more about the package and getting the inside scoop. What to do.
Yeah, I have no problem bothering other people.
And that's difficult if you're not, if you don't have contacts within AMD. So we try to show all of those here. Now we finally build OpenMPI, and we're going to give the paths to all those packages we've built. Okay, next slide. So this is one, and now we're going to create that module file. And this is a good example. What do we need to set? And you might do something slightly different, but it gives you a starting point. Okay, so MPI is one of the most difficult scripts for the installation, probably only rivaled by PyTorch, because PyTorch has lots of friends. So you install PyTorch, and then there's another package to install and another package to install. And I think our builds for PyTorch are around 6 hours right now. So that can, and we often, I gotta say the AMD developers, it used to be when we first started this, there was like a 6-month lag time when a ROCm release would come out before they would get all the patches pushed to the AI libraries. Now they're doing it within a week or two. So they're doing much better. Next slide. Okay, I think that's it. Do we have any questions?
Yes, I think.
Is there anything you?
Yeah.
So are there any questions about software installation? So you really have to think through the software installation and plan to keep everything isolated. And we're trying to keep those tool chains clean, because if you start mixing them, there's going to be bugs that appear. And if you've got your site, you're having the bug, and we're not seeing it with the clean install, we can't really address it. So that's why we're trying to get, how to install things in a fairly clean manner to reduce the number of bugs we're seeing.
So we are using the Mellanox HCA. So do you have any good test?
The Mellanox?
Yeah.
The OSU test should work on the Mellanox, but the flags to build it will be different. And I don't know what they are. We had some issues recently with one of our sites that had HPE, but they were using OpenMPI, their own custom build, and we're having to chase down some issues there. Often the issues with the MPI is in that lowest layer. That software can be pretty ugly, and lots of little bugs there. Usually, whatever MPI uses is pretty solid, but that low-level driver software is really bad. So errors do crop up. Yeah. So what kind of NIC is it for Mellanox?
Connect next.
Okay. Yeah, I don't have it. I think we have some, we got a lot of the systems we have in-house are sort of components we could grab. So we have some with NVIDIA NICs, and I don't know if that's got the Mellanox on it or not. But they use a different transport layer, and we do have issues with that from time to time.
You can have.
We might be able to. I would like to have a copy of everything that we have. We have sites that are using certain combinations. I would like to have a copy of it, but it gets kind of impossible at some point. We'd like to be able to debug things. That's why I want to get PBS working on some of the systems so we can help with PBS issues. I'll ask about Mellanox.
We also use that PBS.
PBS. We have a couple of sites with that, and one of our colleagues, Steve Gambosi, was the lead PBS bug person for all of North America. So we have somebody that can help with those issues. And the batch systems are really specialized. You have to have a lot of expertise in each one of them to know how to actually, configure them properly and manage them. Are you using the open source version or the commercial? Commercial. Okay. Any other questions or? And if you run into a problem, send us a message. If we can answer it quickly, we'll try to help. We can't answer every question. If it takes days to track it down, we may not be able to answer. We'll try to give you some ideas. Or chase somebody else down in our organization that has more knowledge about it. Okay. I think we're ready for the wrap up. So now I gotta restart my network.
Uh-oh.
Is this normal that after 4 or 5 hours, it drops the network?
Yeah.
So I have to go in here and reconnect. This is fine. Okay.